Hello guys, in this video I'll be solving the problem reverse linked lists. This is a common problem in technical interviews, and as a software engineer aspiring to ace your technical interview, it is important you know how to solve this problem. Join me in this video to find out how. Before diving into reversing a linked list, I would like to give a brief review of what a linked list is. A linked list is a data structure that consists of a sequence of nodes. What is a node? A node is a store of data. A node stores two important pieces of information: the data it stores and a link or a reference to the next node in the sequence. The first node in a linked list is the head, while the last node is the tail. The tail of a linked list points to null, and this is to show that the end of the linked list has been reached. I hope you now have an understanding of what a linked list is. Next, I'll go ahead to read the problem statement. Given the head of a singly linked list, reverse the list and return the reversed list. Now, I'll go ahead to give a visual explanation of the solution to this problem. Given a linked list of nodes, I'll call the first node node 1, the next one node 2, the next one node 3, and the last one node 4. Node 1 is the head of the linked list, since it is the first node in the linked list. Node 4 is the tail of the linked list, since it is the last node and it is the node that points to null. After reversing this linked list, the head becomes the tail and the tail becomes the head. So this is the results we are expecting after reversing the linked list. After reversing, node 1 will point to null instead of pointing to node 2. Node 2 will point to node 1 instead of pointing to node 3, and so on. To reverse this linked list, I'll make use of 3 pointers: a current pointer, which I represent with C, a previous pointer, which I represent with P, and the next pointer, which I represent with N. The current pointer points to the current node to be reversed, while the previous pointer points to the node immediately before the current node, and the next pointer points to the node immediately after the current node. Now I'll go ahead to place the pointers. Since the head is the first node in the linked list, I'll place the current pointer on the head. There is no node before the head, so I'll place null before the head, and I'll assign the previous pointer to null. Now I'll assign the next pointer to node 2. Since I have the 3 pointers assigned, I can go ahead to reverse the current node, which is the head. So instead of the current node pointing to node 2, I'll point the current node to null. Now the current node has been reversed. After reversing the current node, I'll move the previous pointer to the next node in the linked list. I'll move the current pointer to node 2, and I'll move the next pointer to node 3. Now that I have all the pointers assigned, I'll go ahead to reverse the current node. So instead of node 2 pointing to node 3, now it will point to node 1. After reversing the current node, which is node 2, I'll move the previous pointer to the node after it. Then I'll move the current pointer to the node after it, and I'll move the next pointer to node 4. Now that I have the 3 nodes assigned, I'll go ahead to reverse the current node, which is node 3. So instead of node 3 pointing to node 4, node 3 now points to node 2. After reversing the current node, I'll move the previous pointer to the next node after it. Then I'll move the current pointer to node 4. And I'll move the next pointer to null. Now that I have all the pointers assigned, I'll go ahead to reverse node 4, which is the current node. So instead of node 4 pointing to null, node 4 now points to node 3. After reversing the current node, I'll go ahead to move the previous pointer to the node after it. Then I'll move the current pointer to null. Now, since I have nowhere to move the next pointer, I'll leave it pointing to null. Now that the current pointer points to null, I'll stop moving the pointers. And this means that I have successfully reversed the linked list. Node 1, which was the previous head, now points to null. So it is now the tail of the linked list, since it's the tail of the linked list that points to null. And then node 4 is now the head of the linked list. Now, this solution will return the head of the linked list, which is node 4. And it is important to note that node 4 is the previous node because you have the previous pointer pointing to it. So this solution will return the previous node. That's it for the visual explanation of this solution. I'll go ahead to implement this solution in code. From the documentation in the comments, a list node is defined. A list node is a node in the linked list. A list node has two properties: a val property, which holds the value of the node, and the next property, which holds a link or a reference to the next node in the sequence. The reverse list function takes the head of the linked list as a parameter. It is important to note that in code, a linked list is represented by its head. And this is because from the head of the linked list, you can access every other node in the linked list. Also from the comments, the head of the linked list is a list node, meaning the head has the val and next properties also. The next thing I'll do is to declare 3 pointers that will point to the current node, the next node, and the previous node. So I'll let the current pointer point to the head. The previous pointer will point to null. And I'll initially let the next pointer point to null too. Now I'm representing the next pointer with nxt so as not to mix this up with the next property of the list node. Also, I'm assigning it to null because before I can assign the next pointer to the next node, I need to confirm that the current node is not null. The next thing I'll do is to declare a loop with which I'll be moving the pointers. Now, for how long will I be moving the pointers? I'll be moving the pointers as long as the current pointer does not point to null. This is the same thing as saying as long as the current node is not equal to null. Now that I have confirmed that the current pointer is not pointing to null, I can assign the next pointer to the next node. Now that I have all the pointers correctly assigned, I'll go ahead to reverse the current node. So the current node now points to the previous node. The next thing I'll do is I'll go ahead to move the pointers. So now the previous pointer will now point to the current node, and then the current pointer will point to the next node. Now, once I'm done with this loop, the linked list would have been reversed. And then I'll go ahead to return the previous node, just like I explained in the visual explanation of the solution. So once the loop is done, I'll return previous. Next, I'll go ahead to run this code for correctness. These are sparse. I'll go ahead to submit, and these are sparse also. The next thing I want to talk about is the time and space complexity of this algorithm. The time complexity of this algorithm is big O of n, while the space complexity is big O of 1, or constant space. The time complexity of this algorithm is big O of n because for me to reverse the linked list, I need to go through each node and reverse it. So if you have a linked list of 3 nodes, these will take 3 operations. If you have a linked list of 10 nodes, these will take 10 operations. If you have a linked list of n nodes, these will take n operations. The space complexity of the algorithm is big O of 1, or constant space, because the extra amount of space used by the algorithm does not grow with the size of the linked list. The extra amount of space used is to keep track of the current node, the next node, and the previous node. So if you have a linked list of 1,000 nodes or a linked list of 1,000,000 nodes, this same extra amount of space will be used, which is why the space complexity of the algorithm is big O of 1. I hope with this implementation, now you know how to reverse a linked list. The link to the code will be included in the description. That's it for this video. If you found this video to be helpful, give it a thumbs up. If you'd like to see more videos like this, subscribe to my channel and hit the notification bell icon. I'll see you guys in the next one. Happy coding.